Hello students, in this video we will be reviewing the lesson 3-4 equilateral triangles. Let's get started with this tuner problem. Use the picture below to find the value of y and the measure of the angle M. Show your work. If you notice in this triangle, we know that angle M is 3y plus 1 and angle N is 2y plus 2. These are both interior angles, and then we know that the measure of the angle NPQ is 48. So we need to be able to recall here supplementary angles in order for us to find the measure of the angle MPN, which is the missing interior angle. So here, in order for us to find that missing interior angle, we would do x plus 48 equals 180. Then subtract 48 from both sides, and we get x equals 132. Once you have all the three interior angles, then you need to be able to solve for y. So you need to set up an equation, right? Let's recall the triangle angle sum theorem that states that when you add the three angles, their sum is going to be equal to 180. So we say 3y plus 1 plus 2y plus 2 plus 132 equals 180. Here we combine the alike terms. 3y plus 2y gives me 5y. Then we add the constant numbers. 1 plus 2 plus 132. We get 135. And notice this is a two-step equation now, so we get rid of the constant first. 5y equals 45. And then divide by 5, and y equals 9. We have found the answer for y, but that was just part of the question. The next part that we have to do is find the measure of the angle M. So M is 3y plus 1, so substitute the y value, 3 times 9 plus 1, and 3 times 9 is 27 plus 1 is 28. So angle M equals 28 degrees. Okay, notice that for this problem, we were able to recall a linear pair or supplementary angles that we learned in Unit 1. And then we also were able to recall the triangle angle sum theorem, which was lesson 3-2. And like I said before, concepts that you learned previously will always pop up again in upcoming lessons. All right, so the objective for today, students will be able to apply properties of equilateral triangles to find the measure of angles and sides. So yesterday we talked about isosceles triangles, and we said that isosceles triangles were going to be those triangles who had two congruent sides and that also had base angles that were congruent. For equilateral triangles, we know that a triangle is equilateral if and only if it's equiangular. So if a triangle, it says here, if a triangle has angles A equal to angle B equals to angle C, then we can conclude that because this triangle is equiangular, it would be equilateral. AB will be congruent, will be equal to BC, which will be equal to AC. Same thing if we say if a triangle has AB equal to BC equal to AC, if all the sides are congruent, then all of the angles will be congruent. The measurement of angle A will be equal to the measurement of angle B, which is equal to the measurement of angle C. Also, if these all three angles are equal to each other, then what would be the measure of each one of the angles? Well, we know that the sum, if I add angle A plus angle B plus angle C, we know that the three interior angles in a triangle always equals to 180. For this particular type of triangle, we know that all of the three angles are equal, right? So x plus x plus x equals 180. We have 3x equals 180. So divide by 3 and x equals 60. So in an equilateral triangle, since all of the angles are equal, then each one of those angles will be equal to 60 degrees. Okay, two things to know about equilateral triangles. Equilateral triangles have all congruent sides and all congruent angles. Also, since the angles are congruent, then each angle will measure exactly 60 degrees. All right, let's go ahead and get started with the practice. Notice we have this triangle. Angle A is 60 degrees, angle B is 60 degrees, and angle C must be 60 degrees as well. And so because this is an equiangular triangle, then it's going to be an equilateral triangle as well. So BC will also be 9 feet, and AC will also be 9 feet. Okay? On the next one. What would be the measure of angle J, angle K, and angle L? Well, if you recall the statement that we just learned, we said if you have an equilateral triangle, which we do in this case because all of the sides have the same number of markings, then because this is an equilateral triangle, it will also be an equiangular triangle. So because all the three angles are equal, each angle will be 60 degrees each. As simple as that. All right, let's go ahead and do the next problem. It says here, if triangle PQR is an equilateral triangle, solve for x and y. So notice, if I want to solve for x, I notice that 7x minus 3 is labeled, is the expression that for the angle R. And they're already telling me in the instructions that this is an equilateral triangle. So that means all the sides are equal, but all the angles will be equal as well. So, because of the angles being all equal, congruent to each other, then we can say that each one of these angles is equal to 60 degrees. And so in order for you to solve for x, you set up your equation, 7x minus 3 equals 60. This is a simple two-step equation. Get rid of the constant. 7x equals 63. And then we get rid of the coefficient. Divide by 7. And x equals 9. We have found x, but now we got to find y. And for y, even though you're giving three different expressions, all that you need is to get two of the expressions and set them equals to each other because all the sides are equal. And we just need two expressions equal to each other to successfully solve for y. So we do 9y plus 1 equals 11y minus 23. Because you have y terms on both sides of the equal sign, move the smallest one, minus 9y. So 1 equals 2y minus 23. And once again, this is a two-step equation, so get rid of the constant. It's 24 equals 2y. Get rid of the coefficient, so y equals 12. Okay. Next problem. Once again, here they're telling you triangle ABC is an equilateral triangle. Find x. We recall the rule that we just learned. If a triangle is equilateral, that means all the sides are equal. But a triangle that is equilateral will also be equiangular. So all of the angles will be equal to 60, and they're all equal to each other. So in order for you to solve for x, set up an equation, 8x minus 44 equals 60. Simple two-step equation, get rid of the constant. 8x equals 104. Get rid of the coefficient. And we get here 104 divided by 8, 13. As simple as that. All right, now we're going to be solving for sides with algebra. Just like we did in the not in the previous problem, but the one before that one. So if triangle ABC is an equilateral triangle, again, they're telling you it's equilateral triangle, put the same number of markings, and they want you to solve for x, and then they want you to solve for y. Well, you know that if this is equilateral, if AB is 49, then BC will also be 49, and AC will also be 49. So those are your two equations that you need in order for you to successfully solve for x and y. 3x plus 1 equals 49. Simple two-step equation, subtract the constant and divide by the coefficient. And we get 16. Now if we want to solve for y, we would say 18y minus 41 equals 49. Get rid of the constant. 18y equals 49 plus 41, which would give me 90. Get rid of the coefficient, and we get 5. Again, because this was an equilateral triangle, you know that each one of the sides will be congruent to each other. So if one side is 49 meters, then all of the other sides will be 49 meters as well. You set up the equations, and then you solve for each one of those missing unknown variables. All right, let's look at the next one. It's a little bit different, this one. If triangle MNP is an equilateral triangle, find x and the measure of each side. Once again, we're giving an expression for each one of the three sides. And also, we know that this is an equilateral triangle, so all the sides are congruent. All you need is to select two. Just pick two of those expressions to set up your equation and solve for x. And then later, come back and substitute that x value to find the measure of each missing side. So I'm going to pick 4x minus 25 equals x plus 14. Again, it doesn't matter which ones you select, which expressions you select, as long as you just select two. Because this is an equilateral triangle and all the sides are equal. And then looking at this equation, we have x terms on both sides of the equal sign. Move the smallest one. Remember, there's an imaginary one there. So I'm going to move the 1x by subtracting 1x. So we get 3x minus 25 equals 14. So plus 25 plus 25, 3x equals 39. Divide by 3, and x equals 13. Okay, now that you know the x value, you need to come back and find the measures of NP, MP, and MN. You need to come back and substitute. So you do And P is x plus 14. We know x is 13, so 13 plus 14, that's going to give us 27. Honestly, if you know the length of one of the sides of an equilateral triangle, then the other two will also be 27. But if you want to double check your work, right, you can just simply do 4 times 27 minus 25, and you see that you get 27. 6 times 27 minus 51, and you're going to see that you get 27. And I made a mistake here, sorry. X is 13, not 27. Oops. There. Okay, so for your independent practice, you will be having problems in which they're asking you to solve for x, and notice that for 1 through 4 they're all equilateral because they're equiangular, right? So here you just gotta set up the two sides equal to each other like that and solve for x. And then you get a problem like the one that we just did, in which they're giving you the 3 different expressions, and you're just going to be picking 2 to set up the equation. That's going to be for the next 3 problems. And then I'm giving you problems for you guys to review. So you have problems from lesson 3-1, which is classifying triangles. You're going to use the distance formula for this one. Let me just copy it for you. x2 minus x1 squared plus y2 minus y1 squared. You find the length of each one of the sides of the triangle, and then you decide if it's a scaling, isosceles, or equilateral. And then you're giving a review for lesson 3-2, which is the interior angle sum theorem, right? And then the exterior angle. So for the exterior angle, I just want to make sure that you review this, the exterior angle. So right now my exterior angle is 19x minus 18. That's going to be equal to the sum of the two non-adjacent angles, which are the 2 remote interior angles. So 7, which are these two. 7x plus 1 equals 10x minus 9. And then at the end, you have a problem of isosceles triangle. And you're going to be recalling the properties of isosceles triangle, drawing the diagram for this particular problem, and solving for x, and then finding the measure of each one of the sides. Super important, guys. You will be expected to complete the independent practice, and then you're going to be expected to take a picture of your work and submit it into the assignment for the lesson 3-4 equilateral triangles. I hope this video was very helpful to you guys, and I'll see you tomorrow with another video.